Welcome everyone. Balanced chemical equations show the ratios involved when reactants form products. Chemists use the mole to quantify amounts of substance. A reactant that is completely used up in a chemical reaction is called the limiting factor. A reactant that is left over at the end of a reaction is said to be in excess. Balanced equations, aqueous moles calculations, and limiting factor are linked ideas that are explored in this walkthrough. This is the format for the walkthrough. It's an AQA A-level chemistry past paper question. Details are in the description. Let's get started. Here's the question. First of all, let's look at the ionic equation. Aqueous barium solutions such as barium chloride are often used as a qualitative test for sulfate ions. If sulfate ions are present, a white precipitate will form BaSO4, which is insoluble. This is studied under Group 2 chemistry. You can save time in exams if you memorise the ionic equations associated with the test for ions on the specification. These include the test for halides, carbonates, and ammonium. If you haven't memorised the ionic equation, you can work it out from the full equation. To derive the full equation, you need to work out the formula of the reactants and products from their names and your knowledge of the charges on ions. The ions of ionic substances move around independently if they are in aqueous solution. Split these up into their constituent ions. There are no covalent substances in this equation. However, for equations which do include covalent substances, you cannot split the covalent substances up because they don't contain ions. The ions of solid ionic substances do not move around independently. They are in fixed positions. Solid ionic substances are not split up into their ions either. Ions that appear on both sides of the equation and are unchanged are called spectator ions. These do not take part in the overall reaction and can be cancelled. The ionic equation is shown in blue. It is very important to show your working out clearly in order to address this part of the question. We can use the equation N is equal to CV to work out the amount in moles of each aqueous reactant. The amount of barium chloride works out to be 1.5 times 10 to the minus 3 moles. The amount of sodium sulfate works out to be 1.2 times 10 to the minus 3 moles. We can see from the balanced equation that this is a one-to-one reaction. The amount of barium chloride present is greater than the amount of sodium sulfate, so barium chloride is in excess. Finally, we'll calculate the total volume of the other reagents which the student should use so that the filtrate contains only one solute. If there are equal amounts of BaCl2 and Na2SO4, the only solute left at the end of the reaction will be NaCl. We can work out the volume of Na2SO4 required using volume is equal to amount divided by concentration. This works out to be 0.010 decimeters cubed. Convert to centimeters cubed by multiplying by 1000. Thanks for watching. Please like, subscribe and hit the bell for notifications. Post in the comments if you have any questions or suggestions. Take care and good luck with your studies.